So we've been talking so far about g of x being a function that is inside of f of x. So we talked about chain rule, the outer layer, right? Like the f function here is the outer layer, and then the inside layer is the g function, right? That's the way we've been referring to things. Now, if we replace g of x by another letter, and it is very unfortunate that math people in the world have chosen u, because f is also the common notation for function, so this becomes fu. As a teacher, it's a little distracting, I find, for my students. However, this is not my doing. So, to be consistent with the material that you are going to ingest over the next few years, I will do this. Would I like to have another letter like A? Yes. Or W? Absolutely. K I wouldn't use. That would be the only one that maybe would be worse. But F of U, okay? So, if you get mad at me, okay, I don't want to hear this coming out of your mouth, okay? F of U, Mr. Maxwell, because I might just misinterpret that. F of U, you mother function. If that comes out of your mouth towards me, I'm going to get really, really upset with you, okay? All right, you got it? I have no idea what I said, right? Okay. Yeah, that's right. I'm looking at you. Okay. Okay, so the chain rule then, if it's f of u, now notice that u is another function. So x is not in here anymore, but it is in there, right? But u just represents another function. This right here is a lot easier to write than this, okay? But what we have to understand is that when we're taking the derivative, we take the derivative of the function f of u, but then we have to multiply it by the derivative of u with respect to x. So that's what this bottom line says. The derivative of the function with respect to u, that's this part, multiplied by the derivative of u with respect to x. So this is now going to lead me to the Leibniz notation for chain rule. So I just wanted to clarify this. Now, Leibniz notation, okay, talks about, it's like this, right? dy over dx, right? This means the derivative of y, so y prime, is sort of what we would say, or we would say f prime of x, right? The derivative of y, the function, f of x, with respect to x. That's what that means. The chain rule becomes this. If you want to find the derivative of y, which is our f of x function, or our f of u function, we would find the derivative, okay, of y with respect to u, and then multiply it by the derivative of u with respect to x. So this right here is the Leibniz notation for the chain rule. It's important to note that this is not a quotient, okay? This is multiplying, but this is really not a quotient. It doesn't really make sense to do derivative of y as an entity on its own and then divide by derivative of u. That doesn't make sense. That's not what we're talking about. But on the same hand, it is helpful for us when we're doing math and when you get into higher levels of differentiation and stuff like this, and related rates maybe even and stuff like that we're going to do later, then this is helpful to view it like this. And you can actually sort of treat it like a quotient that's multiplied by another quotient. You can treat it like that. And so really, you see how when these sort of semi-pseudo cancel out, you get dy over dx. You see that? You just have to put the u in there, and that's called the chain rule. Okay, so it's a roundabout way of finding the derivative, and it's the chain rule. So that's how you'd use Leibniz notation. You'd find the derivative of the function, which would be, of course, f of x. If we scroll up here, f of x, the f function with respect to u, that's what this means right here, and multiply it by the derivative of u with respect to x, and that's what this would mean. Okay? Or you could put, and you might like this as well, I'm not really sure, but you could write like this. U, the derivative of u with respect to x. That's a crazy u right there. My tablet slipped sideways. Okie dokie. Okie Jesse dokie. Just getting that. Yeah. No, it's not live. It's recorded. It's recorded. This is not live. It's not streaming live. No, the throngs of people, like I'm talking to 2 people that will watch this video in the future, they are going to be really excited that I just accidentally mentioned a student's name, which I'm not going to do again because everybody missed it before. Okie dokie. All right.